Okay, welcome back. Let's continue our discussion. We have solved, I think, one problem in our previous video to illustrate how we compute for how we solve for the resultant of system of forces, coplanar forces, and sa first example natin, we have converted this system of forces into a force couple system. So, merong force at saka moment na equivalent yung system of forces. Now, for the second problem, ito naman, iba naman ito, no? Let's try to read it. A couple of magnitude 540 Newton millimeters, that should be Newton millimeters, yung nasa module natin, may konting error sa pag-encode. But when we say couple here, it means moment, couple moment or moment of a couple. We have a moment, it's 540 Newton millimeter, and three forces shown are applied on an angle bracket. This is the angle bracket. Find the resultant of this system of forces and locate the points where the line of action of the resultant intersects the line AB and line BC. So these are lines AB and BC. So saan yung points of intersection between the line of action of the resultant force and these lines. So this time we are not going to convert these forces or system of forces into a force couple system, but we are going to compute for the equivalent resultant force only. So if that is the case, kailangan nating i-locate yung resultant force natin relative to a certain point. Ayan. So saan dapat natin ilalagay yung resultant force so that the effect of the yung system of forces would be equivalent to the effect of the single force na i-compute natin. Alright, so first, of course, is we need to solve for the resultant force. So we have how many forces here? We have three forces, no? So meron tayong inclined force here at point B. So solve natin yung resultant force. Okay? So to solve for the resultant force, kailangan nating just like what we have been doing before. So yung summation of forces along x is equal to the x component or the horizontal component of the resultant force, which is equal to, so ano yung Rx natin? So lahat ng horizontal forces. So yung mga horizontal forces natin, we have ito, tapos yung horizontal component of the 13 Newton force. So itong 13 Newton force natin, meron siyang x and y components. So Rx is equal to, sana? So ito, 30 cosine of 60. That is 30 cosine of 60 degrees minus yan because it's directed to the left. 45 newtons, that is equivalent to, so Rx is negative 30 newtons. Okay, negative 30 newtons, which means that Rx is directed to the left. Next, the y component of the resultant force is equal to the summation of all vertical forces. Okay, so that is the y component of the resultant force. Alright, so Ry, so lahat ng vertical forces, so we have ito, tapos yung vertical component of the 30 Newton force. So we have 30 sine of 60 minus, since downwards, minus 10. So that is equivalent to 15.981 Newton. So that is the vertical component of the resultant force. Now let's solve for the angle, no? Ano yung angle ng ating resultant force? Okay? So direction ng ating resultant force. So we know that the resultant force, yung x component is negative And then the y component is positive. So ano yung, saan ba yun nabanda sa ating Cartesian coordinate system? So yung x is negative, y is positive. Okay. So andito yung ating resultant force, no? Okay. Ito yung resultant force natin. This is Rx. That is Ry. Alright. Okay, so solve natin yung angle of inclination. So theta is equal to the arctangent of tangent opposite over adjacent. Yung opposite side natin is yung Ry ito. So we're solving for theta. Opposite side adjacent. Opposite side natin is 15.981 divided by 30 is equivalent to 28.04 degrees. So that's the angle of inclination of the, or that is the direction of the resultant force from the negative x-axis. Ito yung ating, ayan. Okay? So, nasolve na natin yung resultant. Now, we are to solve for the intersection of yung lines AB and BC, relative intersection of lines AB and BC, and the line of action of the resultant force. Okay? So, how do we do that? Paano ba kasi yun? And, wait lang. Adjust natin yung papel. So, we have this angle bracket. Diba, kinonvert na natin to sa iisang force lang. Okay. So, meron tayong resultant force. Alam natin yung kanyang direction. Okay. So, nakalimutan ko yung ruler. So, ito yung resultant force natin. So, it would now intersect at some point na dito. This is line AB. This is A, this is B, and this is C. Ayan. So, yan yung ating line of action ng resultant force. So, yung angle natin dito is angle theta, which we have solved kanina. So, ano yung location ng points na ito? So, locate the points of intersection of the line of action of the resultant force and lines AB and BC here. So, pwede nating i-locate yung point natin from A or from B. Okay. So, maybe we can, yung nasa module yata, ang reference point natin is from B. So, let's just solve for this distance. So, location ng intersection yan. Let's say this is X and this is Y. Y would be the intersection of the line of action of the resultant force and line BC. And then, ito naman, point of intersection between the line of action of the resultant force and line AB. So, ito yung resultant force natin. Okay? Ayan. Okay na tayo. Okay, next is to apply the principle of moments to solve for the values of x and y. Ito. So, x here, sabi ko na pala kanina, yung x natin, yan. So, how do you solve for the intersection? Ito, yung x distance from B, or you can also pwede rin namang ang reference point natin is point A, so x distance from point A, pwede rin ganon, no? Or dito naman x distance from point C, that's also fine. Okay. But let's just choose point B. Okay, para common yung reference point natin sa line A, B, and BC. So later on, we are going to solve also for the intersection, ito, location ng R natin from point B, Y, yung distance Y natin dyan. So to solve for the location, X, or the intersection, location of the resultant force from point B, no? Dito sa may line AB. We need to use the principle of moments. That means that I have, sinabi ko na kanina, yung moment created by the system of forces, should be equal to the moment created by R, no, at point B. Okay, or whichever reference point we have chosen. Pwede rin point A, pwede rin point C, but then here we have chosen point B. Okay, so I suggest you solve this problem, solve nyo ulit using different reference points. Okay, so you're going to use now the principle of moments. Okay, so ang concept natin is that yung moment, repeat, yung moment ng system of forces natin, system of forces, should be equal to the moment of the resultant force relative to point B. Okay? Okay, so ito na. So ito yung line of action ng R natin. So, yan. At directed at theta angle from the negative x axis. So, meron tayong iba, positive yung y natin, negative yung x. Yan. So, pwede rin ganyan. Maraming ganyan all throughout the line of action. So, this is ry, rx, ry, rx, yan. Okay. So, yung moment dapat nito, r natin, okay, sulat ko na lang dito. Moment of R, the resultant force at point B should be equal to the summation of moments at B. So, summation of these forces and moment na rin at point B. Okay? So, parehas dapat sila ng moment at that particular point. So, ano ba yung mga may moment dun sa may point B? So, ito, may moment, of course, mayroon ito. So, take note, we did not include this dun sa pag-solve ng resultant force, no? Kasi hindi siya force, it's a moment, it's a couple, moment of a couple. Okay? So, ito, pero isasalin natin siya, of course, when we solve for the resultant moment or when we summate moments at a certain point, we have to include this in our equation. Okay? So, ano yung mga may moments? Of course, yung 540 Newton millimeter na couple, which is counterclockwise. So, negative siya. No? Okay. So, negative. Ito, may moment din at point B. Itong 30 Newton force, meron ba siyang moment at point B? So, wala. No? Kasi, wala naman siyang moment arm. Zero yung moment arm niya. So, force times zero moment arm. So, wala siyang moment sa may point B. And then, of course, may moment yung 45 Newton force. Okay? So, yung moment ng resultant force natin at point B, yung Rx natin, wala siyang moment at point B. No? Wala siyang moment at point B. Yung Rx, wala siyang moment arm. Ang meron, of course, yung Ry. Okay? So, Ry at point B, so, ito creates a clockwise moment. So, again, clockwise positive. You may use any sign convention dun sa moment. Pwedeng counterclockwise positive. Yun nasa module, counterclockwise positive. Pero sa discussion natin sa video, clockwise positive para meron tayong variation sa ating sign convention. So, whichever is more convenient to you, ayos lang sa akin. Basta i-indicate nyo yung sign convention later on sa solutions ninyo. Alright? So, yung sa resultant natin, I forgot to solve for the resultant. Yung x and y lang naman ang nilagay ko. Although, yun naman ang kailangan natin sa pag-solve ng points of intersection. No? So, yung resultant natin is simply equal to, solve na lang natin, singit natin. Okay, we have -30 squared. Square root of the quantity, -30 squared plus 15.981 squared. So the resultant force is equal to 33.991 newtons. Alright? So next, yung moment ng natin, resultant force about point B. So dito, hatiin na lang natin ulit sa components niya, Rx and Ry, para mas madaling i-analyze yung kanyang moment arm. So yung Rx natin, wala siyang moment arm at point B, so 0 yung moment ng Rx. Ang may moment is yung Ry. So Ry is 15.981 newtons times its moment arm from B, that is x, x yung hinahanap natin. That should be equal to the moment of this system of forces about point B. So yung 540 newton millimeter na counterclockwise, so minus 540. Moment ng 10 newton force about point B, that is also counterclockwise, so minus 10 times 120 millimeters yung kanyang moment arm. Tapos yung 45 newtons. Again, the 30 newton force, walang moment at point B. Ito meron. So, clockwise yung kanyang rotation. So, that is positive. So, plus 45 times its moment arm from B is 80. So, from this equation, we can now solve for X, or the intersection between the line of action of R and line AB. So X here is 116.388 millimeters. Okay. Ayan. Okay. So we're going to do the same thing dun sa pag-solve ng Y. Okay. So sa pag-solve ng Y distance, or that is the distance location of point of intersection between the line of action of the resultant force and line BC. Okay? So we summate moments, same principle. And medyo hindi nakita yung original figure. But we're going to apply the same principle here. So the moment of the forces, the resultant force at B, is equal to the summation of moments at B. Let's consider this sa my point B. Point B. Again, i-resolve natin yung R into two components, Rx and Ry. So Rx and Ry. Okay? So we have here. What do we have here? Okay, so this time, yung Ry naman, yung walang moment dun sa may point B. Kasi yung Ry natin, wala siyang moment arm, zero moment arm niya sa point B. Ang merong moment at this point is yung Rx. It's a clockwise moment. Yan. Okay, so clockwise yung kanyang moment. Okay, so Rx natin, 30 newtons. So 30 yan. It creates a clockwise moment about B. So we have 30 times Y. That should be Y. Okay. 30 times Y, yung distance natin, from point B, is equal to yung moment ng mga forces natin about point B, considering of course itong point natin dito sa may BC. Okay? So, moment na, of course, meron tayong couple moment na 540. Negative siya kasi nga counterclockwise. Okay? And then moment ng 10 Newton force about B is also counterclockwise. Counterclockwise siya. So, that is negative. So, minus 10 times 120 And then, moment ng 45 Newton force, that is clockwise, so plus 45 times, moment arm niya is 80. Okay? So what is Y? Y is equal to 62 millimeters. Okay? So that's it. Ito yung points of intersection relative to point B, ano? But you can also solve for this points of intersection relative to point C or relative to point A. Okay? You may try it. Okay, you may also try it. Solve it that way. Okay, so that's how we solve for this second problem. Now we'll have another example sa next na video.